Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, today we are going to discuss a concept called as classification techniques. So here, in this lecture, I would like to give a brief idea of what are the various classification techniques available. So we are not going to discuss in detail. So these are the following classification techniques we are going to explore now. I'll give a little brief idea about each classification technique, like logistic regression, decision tree, random forest, support vector machines, naive bayes, neural networks, gradient boosting, ensemble, etc. Let us see one by one quickly. And before we discuss those the various classification techniques, let us try to understand underfitting and overfitting. What is this underfitting and overfitting? Because we will be going to discussing the benefits, pros and cons of each classification techniques. So before that, I would like to give a clarification on this underfitting and overfitting. So previous lecture we discussed a classification like the learning step and also the classification step. So learning step, like we teach the machine learning models by supplying the data. Like suppose if it is a supervised machine learning model, then we'll supply the data with the class labels, that is target label, that is supervised. If it is unsupervised, then without giving the class labels, we'll train the models. So if you supply the data that is with the target labels, so that means that is the way we train the models. So the model training, that is how the model learns from the data means, so model is allowed to see, so whatever the model we are talking, so that model will be allowed to see the data points in the given data set, let us say, and this is the data set and this is the data points, and these are the data points belongs to this data set. And from this diagram we can understand that there are two classes or category of data points on this two-dimensional plot. So what is underfitting? What is a overfitting? So from this you can easily understand, like, and there is a line which is almost separating these two different classes. Like let us say this is one class and this is another class. So these are separated by a line. And if you see this another, the second middle image, here you can see it is not a linear, it's a non-linear relationship. So that from, if you compare this one, let us give a number like 1, 2 and 3. If you observe this number 1 image, so here this is the relationship we identified. It's a linear relationship, a straight line is drawn, so that it could separate the data points belongs to the different classes. Like suppose the circles belongs to the one class and this symbol is belongs to another class. But there is some still a misclassification, like these are not belongs to this class but those are classified. This is a linear relationship, so the accuracy is not a 100%. And similarly the second figure, in the second figure you can see only the two misclassifications. So and also the relationship is a non-linear relationship is identified among the data. And the third one you can see here, if this data is almost hugs each and every data point in this, so this is way, so there is no misclassification. So that means 100% accurately classified the data points. Like all these, the right side of this line, this non-linear line, belongs to the one class, and the left side of this non-linear line belongs to the another class. So here that means in this case underfitting the model, so model means model have to learn from the given data. Here in this underfitting we allowed the model is not allowed to see the each and every data point. Let us take one simple example, the real world general example, to understand much better. Like suppose, let us say one student or one student. So he he's undergone training to play the cricket match. Let us say I don't have much information on this. But it makes sense. So let us say there are 20 variety of balls could be bowled by the bowler. So here this person who want to learn to play or attempt all the balls, they have to we have to give the enough training, that is to face this 20 variety of balls. So then he could perform well, or he could face all 20 varieties. Let us say these are only the maximum number of variety of balls he could. So then if we give enough time, like enough training on each kind of variety of balls, so he would face each ball in any match. Okay, so there will be no problem. But let us say like only the among this 20, only 50 balls we give training to him to play or to attempt to face this 15 balls. So in that case, so he failed to attempt the remaining 5 balls. Okay, so the success rate, the winning chances or a success rate or a scoring more, that would be less compared to this one. So in this case only we are not allowed, right, or the enough training was not given to this particular student. In this case we had given enough training. That means we trained the student to face all these 20 variety of balls. So similarly, in this context of machine learning, when we supply the data, that is from the data the model has to learn. So in this case, the model is not allowed to see the each and every or enough data, enough whatever the knowledge it has to acquire. So the model did not acquire that knowledge. So that's why still there is a misclassification, but that is acceptable. That means here the misclassification, that is not like among this like 1, 2, 3, 4, 5, 6 data points are misclassified. So that is accuracy drops, like suppose 60%. So 60% will not be accepted. So that means the model is not allowed to, there is no enough training given to this model. So that's why the model is not performed well. So we have to allow, or in this example, whatever we discussed, right, giving training to face the 20 balls. Let us say these are the average, the 20 variety of balls a batsman should face. So in that case, we have to give enough training to face this average 20 balls, so that we expect the performance. Similarly, and here we have to give the enough training to the model so that it would perform well. So that is underfitting. That means there's no much training given to the model. So that's why the model accuracy is not good. And similarly, the overfitting. Overfitting means the model is given too much training. That means we allowed the model to see each and every data point in the data set. Let us say these are all the data points in this data set. So we allowed the model to see each and every data point. So that's why it almost hugs each and every data point from this third image, you could understand. So it is clearly separates, right? So there is no misclassification in this case. So in this case, this is also a problem. Overfitting is a problem, underfitting is also a problem. So we have to build a model that is more generalized. Like, so here you can see in the middle second image, right fitting. Right fitting means not too much training and also not too less training. So in that case, the model is expected to perform like this. So we always have to select the model which perform, or the fitting need to be done in this way. So that is overfitting and underfitting. Later we will also discuss, and we will also see some exercise problems also we will calculate. all these things. So now let us quickly, because here I'm not going to discuss in detail about all these classification techniques. My objective is to explore give a brief idea about what are the different classification techniques available. So the first one is a logistic regression. It is a statistical model that uses a logistic function, that is to predict a binary or a multi-class outcomes. So it could be used in a spam detection, customer churn predictions, etc. This logistic regression is very easy to implement and interpret. It works well for the linearly separable data. Like if you go back to the previous example here, and this is a linearly separable data, whereas the non-linear, so we cannot separate like this. This is here. In this case, if you could separate this data linearly, then there will be many misclassifications. So this cannot be separated linearly. And the disadvantage is it assumes a linear relationship between the features and the log odds of the input. Another important classification technique is a decision tree. So we will discuss in detail in the coming lectures about this decision tree, how the decision tree algorithm and how to construct the decision tree. Those will be discussed in the coming lectures. So this is a tree structured model that splits the data based on the features or features to classify the instances in a data set. And applications of this decision tree would be like a credit risk assessment to medical diagnosis. And we already discussed a few other examples of this decision tree in the previous lecture also. And the decision tree advantage is very easy to understand and interpret. It handles the categorical and the numerical data. And it is prone to the overfitting, sensitive to the small data changes. So that's why I just to give a brief idea about what is overfitting and underfitting. So this way of this is a flowchart representation of the decision tree, but actually this information would be represented in the form of rule based. Like if income is high, age is less than 30, and then the outcome is no. If the income is low and the CR is either fair, yes, or excellent, like this. Next, another classification technique is based on the decision tree, that is a random forest. It is an ensemble of decision trees trained on a subset of data using a bagging or improved accuracy. It is mainly used in a fraud detection and the stock market analysis. It reduces the overfitting. It handles the large data sets also. So it can be slow for a large data sets, that is less interpretable than the single trees. Another classification technique is a support vector machines. This classifies the data by finding the hyperplanes. These are the hyperplanes. Finding the hyperplanes that maximizes the margin between the classes. This should be, and this is a one class and this is another class. That margin should be maximized. So those hyperplanes need to be found. Applications like face recognition, text classification, etc. The advantage of this support vector machines are effective for high dimensional data and robust to the overfitting. And whereas the disadvantage, computationally intensive for the large data sets, sensitive to the choice of a kernel and parameters. Like sometimes like nonlinear data, we cannot separate the data by linearly separate the data. In that case, that data need to be transformed into the high dimensional so that we could separate it using non-linear functions. Next classification technique is a k-nearest neighbor, which is very simple non-parametric method that assigns a class based on the majority class of the nearest neighbors. For example, here the middle green color data point represents it's an unknown sample. So we have to find out the class label, or we have to find out to which class this particular new sample belongs to by using this k-nearest neighbor. So if you take the k value, suppose it depends on the number of classes in this data set. So k value, let us say in this case k equal to 3, So that means the 3 nearest neighbors. So in this circle inside, you will see there are 3 nearest neighbors. So among these, we'll consider the voting. Like suppose there are 2 data points belongs to the blue color, that is one class 2, and 1 data point belongs to the class 1. So that means, so here the blue color data points have the majority of voting. So that's why then it could be it could be classified as a, it the class label of this data point would be class 2. So suppose sometimes it may not be possible to take the k value very small, because even like if your data set has outliers, then that would influence more. So that then the decision would be biased. So we have to take the optimal k value so that the decision would be correct. So like suppose here the k value is equal to 7, that means we are going to take the opinion, or we are going to take the majority, that is a 7, who are near to this. Near in the sense the data, the distance, we use the different distance measures, that is to find out the distance from the unknown sample to the known samples in this. So that based on that distance, we'll identify, suppose if the k is equal to 7, so we have to collect the 7 nearest neighbors. It could be the data points could belongs to any other class. Then we have to count the voting. Like suppose within this k equal to 7 in this circle, so how many data points are there belongs to the each class. So suppose if you count like the red color, red color data points, there are 3, like 1 2 3, and the blue color are 1 2 3 4. So red equal to 3 and blue equal to the voting is 4. So majority blue. So then this would be belongs to the category of second class. So this is the way we find out we apply this k nearest neighbors to classify. Next one is a naive base. It is a probabilistic, that is mainly the conditional probability, based on the conditional probability. So this, it assumes that the feature independence, the applications mainly like in email filtering, sentiment analysis. Advantages with this naive base is very fast, and it works well with the small data sets. And the disadvantage is it assumes the independence between the features may not perform well with the correlated features. So if you could see the formula, probability of A given B equal to probability of B given A times probability of A over probability of B. So these are called as, like suppose probability of A, this is called as a prior probability. That means the probability A being true, this is the knowledge, and probability of B is a marginalization constant. So that is the probability B being true, and this one is the likelihood, the probability of B being true given A is true, and then the probability of A given B is a posterior probability, that is the probability of A being true given B is true. Like suppose the probability of buy given holiday. So that means, so the customers are given like suppose if it is a holiday, weekend or weekday, or the discount is given, or free delivery. So then we could find out the probability, like if it is a holiday, what could be the probability of buying, customer would buy the product. So that kind of the conditional probabilities would be measured based on this base theory. Next, neural networks. It is mainly the network of layers, that like suppose here the input layer or hidden layer and output layers. These non-linear decision boundaries are used to classify the tasks. Applications mainly like image recognition, voice recognition, etc. So that we could, in this by using these neural networks, we understand the features in deep. Like suppose if you take the image classification, like there are like cat images, rat and dog images, like that. So it first identifies the very low level features, and then the next level like that, so that the classification accuracy would be more. Advantages of these neural networks are it could handle the complex relationships, adaptable to the various data types, etc. The disadvantage is it requires a large data sets, so computationally expensive. All the like deep learning models mainly computationally expensive. It requires more computational time and the storage, etc. Because there will be millions or billions of parameters need to be tuned. Next, gradient boosting algorithm. This is like XGBoost, CAD boost, etc. It builds an ensemble of weak learners. Ensemble is a combination of two or more machine learning algorithms. So by optimizing the loss function iteratively, applications like customer segmentation, click-through rate prediction, and advantage is high accuracy. It handles some missing data and outliers very well. And the disadvantage is it can be slow to train, sensitive to hyperparameters. Next, linear discriminant analysis, LDA. It is a technique to reduce the dimensionality, mainly because as I said many times, all the features in a data set may not be important or may not equally contribute. So in that case, the dimensionality need to be reduced. The number of features which are not contributing more or contributing zero, neutral features, like those kind of features would be reduced by using this kind of LDAs. Application like a face recognition, gene classifications. So if you look at the advantages, it works well for the linearly separable data, reduces the overfitting in high. But a disadvantage, it assumes the normal distribution of the classes. Next, ensemble methods like bagging, boosting, stacking. These combine the multiple classifiers to improve the prediction accuracy. Applications, it could be applied to any domain requiring the robust classification models. It reduces bias and variance, improves the model generalization. As we discussed, the overfitting, underfitting, right? The model should not be overfitting as well as underfitting. It should be generalized model. So the improve the model generalization. That means the accuracy, the classification would be more accurate. So increase the computational complexity is the one disadvantage with this ensemble methods. So thank you for watching this video. Next, we'll see the decision tree induction.